Hello friends, welcome to the session on linked lists. So linked list is a data structure often used to store similar kind of data in memory, right? So here is the linked list which you can see, right? So this linked list consists of nodes, right? So this individual elements of the linked list are called as node. So this is the typical node, structure of a typical node. The node has two parts. The first part is called as data part, in which we store actual data, right? And the other part is called as pointer part. In this part we store the address of the next node in the linked list. For example, in this node in the first part of this node we have stored data. The data here in this case is simple integer value. In the second part of the node we have stored the address of the next node in the linked list. So this is the next node in this linked list. So 100 is the memory address of this node. We have stored this 100 in this part, right? So the elements. Now the second thing about linked list is these nodes are not contiguous, right? So if you see, this first node is on 200 memory location, the second node is on 100 memory location, the third node is on 400 memory location, the fourth node is on 300 memory location. So they are not contiguous, they are not created in the contiguous memory, right? So even though they are not in the contiguous memory, so we have a link between these two nodes, between among the node of this linked list. For example, this node is linked to this, or this node is storing address of this node is storing address of this node is storing address of this node. That means I can reach let's say I can reach from first node to any other node in the linked list by using these links. I can traverse the entire linked list. Now, as far as arrays are concerned, the elements of an array occupy contiguous memory locations, and those of linked lists are not constrained to be stored in adjacent locations. As we have just now seen, the linked list node are not constrained to be adjacent. That means if the first node is on 200 location, the other node or second node may be on any other location, right? For example, in this case it is on 100 memory locations, right? But in case of array, the elements in the array are stored in contiguous memory location. For example, if this is array A of integers, let's say 100 integers array. Now this 100 integers array will need contiguous memory, right? So if the first element of the array is stored on 100 memory address, so the second element will be stored here on 103, because this location will need 2 bytes, right? So first bytes address is 100, second byte address will be 101, right? So this 100 and 101 will be given for first location. Now the second element or second location of the array will start at 103 and will end at 104, right? Similarly, third will start at 105 and will end at 106. Likewise, the array elements are stored in contiguous memory locations. That is not constraint for linked list. Now the third point about linked list is the individual elements are stored anywhere in memory but are interlinked. So as we have discussed already, so the individual elements of the linked list are stored anywhere. For example, this is stored on 200, this is stored on 100, this is stored on 400, and so on and so forth. So they can be stored anywhere. Right? Now let's see the advantages of linked lists over array. What are the advantages of linked list over array? Right? The first advantage is arrays have a fixed size. So for example, if we create an array of, let's say, array A, which is integer array of 100 locations, right? Now this array A will be of fixed size. It will have 100 locations only. In every location you will be storing one integer value. Now if you try to at the runtime, you can't change the size of this array, right? You can't store more than 100 integers in this array, right? If you try to do that, your program may crash, right? And at runtime, let's say if you store only 10 integers in this array, the remaining 90 locations will get wasted, right? So that's the drawback of array. It has fixed memory allocation, it has fixed size. You can't change the size of array at runtime, right? But in case of linked list, we can we demand memory dynamically, right? We can have the exact memory required. For example, if I want to store 100 data or 100 records in the linked list, I will demand that much memory only, right? So the memory wastage in case of linked list is less, or we can have as much memory as we want in case of a linked list. Second advantage of linked list over array is array elements are always stored in contiguous memory locations, as we have just now discussed, right? Array elements are always stored in contiguous memory locations, right? The drawback of this is if you need let's say 100 bytes for creating an array, and let's say there are no 100 contiguous bytes free in the free memory pool, right? Though there are 100 bytes free, but they are not contiguous, right? So you will not be able to create an array of 100 bytes. For example, what I mean is, if you need 100 bytes contiguous, right? So to create some array, let's say B, right? You need 1000 bytes, let's say, and those 1000 contiguous free bytes are not available in memory, though our memory is having 1000 bytes available, but they might not be contiguous. For example, here I may have 100 bytes available. On other location I may have 500 bytes, right? And on the other location I may have, let's say, 500 more, right? So these add up to more than 1000, but I can't create my array by using this memory because this is not contiguous memory. But in case of linked list, that's not the constraint. I can have few nodes here, I can have few nodes here, I can have few nodes here, and they can be interlinked then, right? So the second advantage of the linked list over array is linked list don't need contiguous memory, whereas array needs, right? Now the third advantage of array over linked list is operation like insertion of a new element and deletion of an existing element from the array are tedious. So what do I mean by this is, let's say if this is my array of integers 10, 5, 4, 3, 7, 8 and a few empty locations. So now let's say I want to insert an element on this location in between 4 and 3. I want to insert a new element between 4 and 3. So in that case, what I'll need to do is I need to shift the elements starting from 3 onwards. All elements starting from 3 onwards, I need to shift towards right one place, right? So that's a tedious job. Yeah. Similarly, if I want to delete some element from the array, let's say I want to delete this 4, right? So in case of deletion, I need to shift all the elements starting from 3 onwards to left one place, right? So in case of insertion, I need to shift all the elements towards right one place. In case of deletion, I need to shift all the elements towards left one place, right? But in case of linked list, that's not the thing. I need not shift anything, right? For example, if I want to insert a node in the linked list, if I have a linked list which looks like this, and if I want to insert a node between these two nodes, what I'll do is I'll simply create a node, right? And then I'll point the next point. I'll point the next point of this node to this, and then the next pointer of this node to this. So I need not shift anything towards left or right in case of insertion. Similarly, in case of deletion, if I have the linked list which looks like this, and let's say I want to delete this. So if I want to delete this, I will simply make the next point of this node pointing to this node, right? So deletion is also very simple in case of linked list. So these are few advantages of linked list over arrays. The first advantage being array have fixed size, so we can't increment or decrement size of array at runtime. So this can cause program crash sometime or memory wastage. So second advantage of array is array elements are stored in contiguous memory locations. So if we need 1000 bytes, 1000 contiguous bytes of memory free may not be there, but non-contiguous memory may be there. So if you have linked list, you can get that non-contiguous memory, but in case of array, you will not be able to create an array. So the third advantage is operations like insertion and deletion are simple in case of array, whereas in case of operations like insertion and deletion are simple in case of linked lists, whereas they are tough in case of arrays, because you need to shift many elements towards left or towards right. So thank you.